Hi guys, this is going to be a quick video on how to use Desmos to find a line of regression. First of all, when you go into Desmos, you go into this plus over here on the left, and that allows you to insert some things. I want to insert a table, and I'm just going to make up some data. So give me a second to put some data in here. Okay, now that I've got some data in here, my points are over here on my screen. I'm going to zoom it down so we can see where those points are and just recenter my graph. Something like that, just so I can see what's going on. Now, in the next line, you can put in, like for instance, my first one's going to be y equals mx plus b. I can put in y equals mx plus b and see if this is a line. But to do the regression, when you get the statistics and everything, what you do is you type in y1, and it automatically does a subscript, which is what you want. And then you do the approximately equal to, which that's the best that Desmos can do, which is fine. It's right next to the 1. It's the shift and then right next to the 1. And then I'm going to do mx1. And so it shows me where that line of regression would be. It tells me what the slope is. I'm not seeing on there what the, well, I guess I know the y-intercept, so I've got that. So anyway, this is one way that you can do a linear regression. Well, let's say you don't know if it's linear, and maybe you want to see if it's a parabola. I will tell you this is the first time I've done this, so what you can do is put in any quadratic equation. So when I did it a minute ago, I did y1 approximately equal to ax1 squared plus bx1 plus c. And it drew in my parabola. I'm going to hide my line here, but here's my parabola. And if you look at the line, the r value, it looks like it fits the parabolic curve a lot better than it fits the linear curve. And the way I know that is this r squared value is my correlation coefficient. And this one's at 0.96 and this one's at 0.99. So I would say this one is fitting a lot better than the linear. Okay, and then I can also try another one. And so for instance, maybe it's not quadratic, maybe it's exponential. And so I'm going to type in y1 is approximately equal to ab to the x1. And I get this one, and I'm going to hide the other one for just a second. And it doesn't fit as well, does it? It's better than the linear. Down here, my r squared value is 0.97, which is better than the 0.96. But still, the quadratic is much better, isn't it? So that's how you can do it. You can put in any equation that you know. Actually, let's see, because maybe it's logarithmic. And I wasn't sure. You do have to know your parent functions to do this, right? Like I had to know y equals mx plus b. I had to know this quadratic. I had to know this exponential. But if I put it in as a log, let me try y1 is approximately equal to a times the log of x1. And it's not doing anything. And I have this error message here. So I'm going to click on my error message, and it says we couldn't find any region where this model is defined. In other words, it's definitely not a log. Okay, I think that is what that is saying. So that is how you can do a regression. So for your scatter plots, you can do this on your TI-84, or you can do it here in Desmos and come up with which one you think it works. I think this quadratic is the better one. If I needed to take a screenshot of this, I could take a screenshot of this and insert it into a document. If you go into settings, I'm looking for add a label. So if I wanted to put on here time and height, I just made that up, but and I'm going to go into projector mode just for a minute. Okay, so now if I take a screenshot, I have my axes. I'm going to go back and change those labels. I'm going to say time is in seconds and height is in meters. And I'm going to close this. And now, again, I could take a screenshot of this, and I've got my labels, my axes labeled, and I've got my tick marks shown. So that's one way you can use Desmos for this. Before I leave, I'm going to name this. If you don't have a Desmos account yet, you ought to get a Desmos account because you can save some stuff. So I'm going to title this Regression Video. And that way I've got it. Okay, if you've got further questions, you can make sure you let me know and I'll try to answer your questions.